Assalamualaikum and hi, my name is Muhammad Zamir bin Iberahim. My metric number is DN200082 and my supervisor name is Cik Sumaya binti Masuri. I am going to present about my final year project, which is automated rolling brush and water sprayer for cleaning solar panels. First of all, as we can see here, this is a table of content for my slide that I will be presenting. Next, the problem statement of the project. The most effective way to eliminate the effect of accumulated dust is to clean the solar panels. Conventional cleaning method was done manually. Even though the conventional cleaning method is very efficient and effectively cleans the system, it also has several drawbacks, including the potential for staff injuries, costly, time-consuming for large-scale capacity, panel damage, mobility issues, and poor maintenance. In comparison to the conventional approach, automatic cleaning technology with a variety of mechanisms such as automated brushes, water spraying, vacuum suction cleaners, electrostatic cleaning, ultrasonic cleaning, coating methods, chemical solution, robotic arms, and dry cleaning performs better. However, each cleaning method has benefits and drawbacks. The study demonstrates that rolling brush is lightweight, cost-effective, and can function without human intervention, while spraying water over PV is cost-effective, capable of lowering PV temperature, usable in hot weather, and enhance PV cell performance by up to 3.26%. In order to clean the solar panels, an automatic rolling brush and water sprayer mechanism is suggested in this project. The following are the project objectives that must be achieved by the end of the project. Number one is to develop an automatic cleaning system using a rolling brush and water sprayer to get a better performance of the solar system. Number two is to integrate the cleaning system with the solar power storage. And number three is to evaluate the effectiveness of the cleaning mechanism that are used to clean the solar panels. Project scopes based on the objectives set out above are: this project will be represented by developing a small prototype of house and a set of solar panels will be put on the top of the roof. This automatic cleaning system is specially designed for residential house that are using solar power system only. Capable of clean the solar panel by using a microfiber brush and a mixture of liquid in only one or two cleaning cycle. For data collection of the solar panel efficiency is going to be made around Kolej Kediaman Pagoh, HM Johor. Numerous studies have been conducted to investigate the effect of the cleaning methods on the performance of PV system due to dirt, dust accumulation, atmospheric pollution, and bird droppings problems. This slide is focusing on recently developed automatic cleaning system of solar cells, including Heliotex, which is water sprayer with nozzles, and automated brushes. Nowadays, these mechanisms are very mature and employed for cleaning solar panels. As we can see here, this is a table for general comparison of 8 case study cleaning mechanisms on solar PV performance. This table consists of scholars, proposed method, mechanism, advantages, disadvantages, and method efficiency. Number one proposed method is wiper blade system. This method efficiency is up to 30%. Number two proposed method is the water-free brush cleaning system. This method efficiency is up to 9% over the entire month. Number three proposed method is using a rolling brush system. This method uh, have no data yet. Number 4 proposed method is a robotic dry cleaning of solar panels. This method efficiency is the average performance loss of a solar power plant on average is about 1.5%. Number 5 is using an automatic and integrated solar panel cleaning robotic arm. This method efficiency is up to 9.1%. Number 6 proposed method is an alternative cooling method uses water sprayer on photovoltaic panel surfaces. At the back surface cooling increase of 3.6%, at the front surface cooling increase of 2.5% and simultaneous cooling efficiency increase of 5.9%. Next, the proposed method is Heliotex automatic solar panel cleaning system. This method efficiency is up to 95%. And lastly, the proposed method is clean the dust deposit on PV panels using the minimum amount of water and energy. This method efficiency is up to 3%. The flowchart shows the procedure from the start to the end of the system for my project. Initially, when the system is connected to a power supply and is turned on, all sensor, microcontroller, and output function is active. The light dependent sensor, which is LDR sensor, measure the value as soon as the sun rises and the system is set up to begin functioning at the start of the day, usually between 10 a.m. and 11 a.m. Even if there is no dust on the panel surface, the proposed system tracks the sunlight to begin operation every morning. When LDR sends sunlight, water pump will begin to energize and spray the mixture of water onto the solar panel surface. Water pump will be running for 10 seconds before it stops. Next, after all area of the solar panel has been sprayed, the timer will begin counting for 3 minutes. It is because when the mixture of water sits for a few minutes, the acidity will help cut through grease easily, especially birds droppings. After 3 minutes, DC motor for rolling the brush and brush movement start to energize. For the brush movement, it will be set a timer for 5 seconds downward and 5 seconds upward. This system will only be running for only one cycle only. This slide shows a simplified block diagram of the project. One unit of Arduino is used as the main controller unit. Arduino was powered by an external 9-volt DC battery. The system consists of two input sensors which are LDR sensor and water level indicator connected to Arduino. In addition, there are two outputs which connected with relay timing control module to control the timing of diaphragm pump to spray water onto the solar panel and the timing the L energize the motor driver which runs a command to control all four DC motors. Arduino also will connect to LED and buzzer as a signal to user that the water level in the tank is low. The wiring diagram for every component of system hardware is shown here. The cost for made this circuit will be shown on the next slide. The list of components and bill of material required to develop the automated rolling brush and water sprayer for cleaning solar panels are shown in this table. The price is determined by the calculation based on the current market price and the local store they offer, and it may vary over time. From this table, we can calculate that the total cost for this project is about 535 ringgit and 8 cents. This system required of one Arduino, one motor driver, four DC motor, one LDR, one 9-volt battery, one diaphragm water pump, one water tank, four small robot rubber wheel, one 10-meter automatic watering kits, micro misting spray, 10 microfiber mop head close, two 18-volt 10-watt polycrystalline A-grade solar panel, one 12-volt battery, one solar charger controller, one PVC pipe, one handwood molding, two plywood board, two pine wood planks, two relay timing control module, and one water level sensor. Next, preliminary results. A simulation will be used to get a preliminary result. This project simulation was created using the Tinkercad online Arduino simulator. Tinkercad is a free web app for 3D design, electronics, and coding. For project simulation, it consists of three parts with different circuits and functions. The first part shows the hardware connection for water level indicator. The second part will talk about LDR connection to energize the diaphragm pump. The third part is the hardware development for motor driver that controlling 4 DC motor. For the first part, for water level indicator simulation, when the water level falls below or equals 25%, the red LED for the water level indicator simulation will turn on, and the buzzer will begin to sound. The actual water level sensor is replaced in the simulation with a DIP switch SPST times 4 device. Even though the simulation's components may change, the goal was, however, attained. The LCD display is utilized to show the water level in the simulation. The second part is to energize the diaphragm pump with the LDR sensor. The LDR sensor will initially detect the presence of light in the water sprayer simulation. When to activate the diaphragm pump can be controlled by the amount of light sensed by the LDR. The simulation's coding for LDR sensor has been set to above 500. In the serial monitor seen in the Tinkercad web, a light bulb will switch on when the LDR sensor reaches a value of 500 or above. In this simulation, the light bulb represents a diaphragm pump. The third part of the simulation is the L293D motor driver IC is utilized to control the speed and direction of the DC motor in order to simulate the rolling brush mechanism. A DC motor on the right side operates the rolling brush movement, while a DC motor on the left side rotates the brush. The rotation and speed of the DC motor can be managed by simulation coding. The DC motor speed is displayed on top of it. The brush will move at a slower speed than the DC motor does when rolling the brush. Right side DC motor rotation will differ from left side DC motor rotation. The negative speed indicates that it will move downward or anti-clockwise. The expected outcome for this project is as follows. Number one is LDR sensor can detect the sunlight efficiently and can activate the mechanism between 10 a.m. until 11 a.m. Number two is the prototype design can clean the solar panel for only 1 watt. Number three is the mixture of water such as vinegar with water or other chemical solution can be more effective way to clean dirt on solar panels. In conclusion, by knowing the expected result, the automated rolling brush and water sprayer for cleaning solar panel system is the effective way to clean solar panel without damaging it. The system is semi-automated because it only needs human to refill the water in the tank regularly. This table shows my Gantt chart for final year project 1. For the first week, I will be brainstorming idea for proposed project. For the second week, it will be FFP1 briefing and report writing, workshop, supervisor registration. For the third week, it will be e-project online submission of topic proposal. For the third week, I already do a literature review. Literature review, I will do. I have do week 3 until week 11. For hardware price and usage survey, I have do at week 4. For hardware confirmation and purchase, I have do at week 5. For report preparation and writing, video and preparation, I have do at week 6 until week 13. For report submission, correction, preparation for presentation, I have do at week 13. For FFP1 video presentation submission to panels and Q&A session with panel, I will do at week 14. Next for Gantt chart table FYP2. Literature reviews I will do at first week until week 11. For assemble of the system with controller, I will do at first week until fourth week. For development of Arduino code for sensor, I will do at week 5 and until week 7. For installation of the system, I will do at week 8 until week 11. For test run for the system under the sun, I will do at week 11 and week 12. Uh, for modification of code, if any, I will do at week 11 and 12 also. FYP2 report preparation and writing, I will do from first week until week 12. For final report submission and preparation for presentation, it will be at week 12 and week 13. For FYP2 presentation, it will be at week 14. This slide shows my reference for this project. Thank you.